Perfect. Okay, guys. So let's get started without any further ado. As mentioned earlier, oh, is the session being recorded? Right. So as mentioned in today's class, we shall be going with the new topic, networking fundamentals, one of the most important prerequisites for cybersecurity. Okay, understanding what networking is, what networks are, what are hosts, and how do they communicate with each other, what are IP addresses, and what are some networking protocols is what we'll be learning today and in the upcoming sessions as well. Okay. So to define networking first, basically, it is the practice of connecting information devices with each other. And why do we need to do that? In order to share data, information, or resources with each other. Okay. So basically, all connectivity that happens in today's world among these devices is all possible through various forms of networking, whether it be in a wide medium or a wireless medium. Okay. So when there is a connection between, again, your system to my system over here for this Zoom call or for this GoToMeeting, all of this is happening on the basis of your connection being transferred or your packets being transferred from your device to your Wi-Fi router. Okay, and then from the Wi-Fi router in a wired connection to the ISP servers, and from there to another ISP and another ISP, and from there to my ISP. Okay, and then coming to my system. So all of this is a huge network. Okay, and the practice of connecting these information devices with each other to share that data is called as networking. Okay. When you talk about a network now, as mentioned, it is a collection of interconnected devices, computers, servers, printers, mobile phones, routers, so that all of these devices can communicate with each other. All of those devices collectively are called as a network. Okay. And each of those individual devices is called as a host. Okay. So when you connect any device to a network so that it can transmit or receive data, that individual singular device is called as a host. Okay. So again, you have multiple examples of it. Again, your PCs, your headphones, your IP cameras, your smartwatches, your smartphones, printers, your earphones, Bluetooth headphones, etc., etc. Each of this is known as a host itself. Okay. Now, just like how we humans communicate with each other and to address each other, we have our respective names. These devices also have an identity. That identity is called as an IP address. It stands for Internet Protocol Address. So this was actually invented by the US military in the late 1950s or so. And there were multiple versions of it. Some were experimental versions and some were production state versions. Okay. So IPv1, V2, V3 were experimental. What successfully worked out was IPv4, Internet Protocol version 4. And we're still using that version 4 even in today's world. Okay. To define what an IP address is first, as mentioned, each device or each host on the network has a unique identifier. So that unique identification is called as an IP address. And these IP addresses allow a communication to occur between multiple devices in a network, okay, or across networks as well. Now, this IPv4 address that we are talking about has a few important properties to it, guys. Okay. Firstly, it's a 32-bit address. Now, what do I mean by a 32-bit address? So your bit is the smallest data value any information system can hold. Okay? So the smallest value that a computer or any information device can hold or transmit is called a bit. And it can either contain the value 0 or the value 1. Because 0 is like the off signal and 1 is like the on signal. Okay. And your IPv4 address is a composition of 32 bits. It has 32 zeros and ones consecutively. Okay. And that entire 32-bit portion or the 32-bit IP address is divided in 4 equal parts again, where each part consists of 8 bits in it. And each of that 8-bit portion is called as an octet. And each octet is separated by a browser. So this is what your typical IPv4 address looks like in the binary format, in the language of zeros and ones. Okay, binary in the sense only 2 characters, 0 or 1. Okay, so you have 8 bits here, then you have a dot, then another 8 bits here, then a dot, then another 8 bits here, then a dot, and then another 8 bits here. Okay, so like that, 32 bits in total. Okay, but this number here is something which is only understandable by information devices, computers, example. Okay, we humans don't easily understand binary. What we regularly use are decimal numbers, numbers like these. Okay, so this number 11000000 can actually be converted to 192. This number 10101000 is actually equal to 168. This number, all zeros, is simply zero. And this number 00001010 is 10. Okay. So now we'll be learning how do you convert any binary number to a human readable decimal number. And I'll also explain why that is important in a while. Okay. So any questions up to this point, Mahinder or Surya?
No, sir.
I'm good, Shiva. Sorry. Mm. Yeah.
Okay, perfect. Now let's talk about the conversion. So in order to convert any binary number to a human readable decimal number, there are two simple rules to it. Rule number one is you write down the values of 2 power 0 all the way up to 2 power 7 from right to left. So for example, if we take this binary number here, an octet here, 10101010, step number one is, excuse me. Step number one is you assign the value of 2 power under each bit from right to left. So under the rightmost bit, you have 2 power 0, then you have 2 power 1, then you have 2 power 2, then 2 power 3, then 2 power 4, then 2 power 5, then 2 power 6, and then 2 power 7. So from right to left under each bit, you're writing down these values. Once those values are written down, then you multiply the lower value with the top bit and keep on adding it to the next one. So multiply the lower bit with the top one, add it to the next one. Multiply, add, multiply, add, multiply, add. And that way you would get the final decimal value for the binary number. Excuse me, bit of a cold and sore throat today. So again, now if we start calculating this, let me write down the values first for these numbers from 2 power 0 to 2 power 7, guys. Anything to the power 0 is always equal to 1. It's a mathematical rule. 2 power 1 is 2 itself. 2 power 2 is 2 into 2, that's 4. 2 power 3 is 2 into 2 into 2, 3 times, that's 8. 2 power 4 is 2 into 2 into 2 into 2, 4 times, that's 16. 2 power 5 is 32, 2 power 6 is 64, 2 power 7 is 128. Now, since you have these values, you multiply that value with the top bit. 2 power 0 into 0. That's simply 0. Plus 2 power 1 into 1. 2 power 1 is 2. 2 into 1, that's 2 again. 2 power 2 into 0, 0. 2 power 3 into 1, 8. 2 power 4 into 0, 0. 2 power 5 into 1, 32. 2 power 6 into 0, 0. 2 power 7 into 1, 128. And if you add all this up now, 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer understands it as 10101010. It's something like high frequency, low frequency, high frequency, low frequency, high frequency, low frequency, high, low. Okay. So when that exact sequence of frequencies flows through a computer, it understands it as a number 170. Okay. So that is how you convert any binary number to a human readable decimal number, guys. Any questions regarding this conversion? Do you want me to explain anything again? I hope this is clear. I'll explain in a bit why this is important as well, guys. But any questions regarding this? Excuse me. Okay, perfect. If this is clear, guys, I have two other numbers here. And if you have a pen and a paper beside you, I would want you to calculate the answer for these numbers: 01010101 and all ones. Okay. So again, the first number is 01010101. Second number is all ones. So if you have a pen and a paper beside you, I want you to calculate and give me the decimal answers for that. Take your time, no rush. Correct answer, Surya. Mahinder, any answers on your end? Okay, let's try clarifying the first one now, just in case if you're still trying to calculate this Mahinder. Okay, so there's 0, 1, 0, 1, 0, 1, 0, 1. So same logic, multiply the lower value with the top bit. So 2 power 0 into 1, that's 1. 2 power 1 into 0, 0. 2 power 2 into 2, sorry, 2 power 2 into 1, that's 4. 2 power 3 into 0, 0 again. 2 power 4 into 1, 16. 2 power 5 into 0, 0 again. 2 power 6 into 1, 64. And 2 power 7 into 0, 0 again. So when you add all this up, 64 plus 16, that's 80. 80 plus 4, 84. 84 plus 1, 85. Okay. And when you have all ones, you just add all the values. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And when you convert that, you get 255 there. Okay. 255, mind, maybe some slight miscalculation. Okay, but if you cross check it again, you would get 255 there. 120 again, 1 plus 2, 3, 3 plus 4, 7, 7 plus 8, 15, 15 plus 16, 31, 31 plus 32, 63, 63 plus 64, 127, 127 plus 128, 255. Okay,
Sorry,
so,
it's my bad. Yeah, it's 255.
so oh, perfect, perfect. Right. Right. So again, now the reason I'm explaining this calculation, guys, is because when you talk about the first IP or the last IP, a simple method is to put all zeros everywhere in the first octet. Okay. So when you put all zeros everywhere, you get the first IP as 0 dot 0 dot 0 dot 0. Okay. And if I had to get the last IP, all I have to do is put all ones everywhere. And when I put all ones everywhere, I get the last IP as 255.255.255.255. So from this, we can understand that no matter what IP address you take, those IPs can never exceed the number 255 because in an octet, when you put all ones, the maximum it can go is 255 itself. So you would never have an IP above the number 255. Okay. And if someone asks you how many IPs are there in total, each bit has two possibilities, either a 0 or a 1. So when you calculate the number of possibilities, it would be 2 into 2 into 2 into 2 into 2, all the way 32 times. So 2 raised to the power 32 is equal to 4.3 billion IP addresses. So in total, from the first IP till the last IP, there's a total of 4.3 billion IP addresses. Okay. So back then in 1950s or so, when these IP addresses were invented, they thought 4.3 billion IPs is a very large number. But fast forward to 2024, population itself is 8 billion people. And each person again has multiple devices, right? So again, that's why these IPs are categorized again. There's public IPs, private IPs, classes and IPs. So we'll talk about all that later. Today, we'll talk about the sequence of these IPs. So we know the first IP is 0000. Last IP is 255, 255, 255, 255. But what about the sequence of IPs? How does the sequence flow? So today we'll talk about the sequence now. Okay. To understand the sequence, again, there are two simple rules, guys. Let me show you. So I'll open up a notepad file for this. Now, we all know the first IP is 0000. Right. So if you want to get the next IP, rule number one is you start incrementing always from the rightmost octet. So if this is the first IP, next IP would be 0001. Next IP is 0002. Next IP is 0003. So you're just incrementing or increasing the value by the rightmost octet by one. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the way goes up to 255. So 000 255. Now, after this, please note you cannot have an IP like 000 256. This is wrong, invalid. Okay. You can never have any octet exceeding the number 255. Okay, very important. Okay. Now, once it reaches 255 here, then comes rule number two. Again, once the rightmost octet reaches the maximum value, then you move to the left octet. Okay. So now the left octet, this one increases by 1. Okay. So after 0, 0, 0, 2, 5, 5, then you have 0, 0, 1, 0. Okay. Then 0, 0, 1, 1. Okay, remember, always increment the rightmost octet. So don't directly jump from 0010 to 0020. That would be wrong. Remember, rule number 1, always increment the rightmost octet. Okay, so this 10 changes to 11, 12, 13, 14, 15, goes up to 1255, then you have 20. Okay, then this 20 goes to 21, 22, 23, 24, 25, which goes up to 2255, 30 to 3255, 40 to 4255, 50 to 5255. So I'm skipping a lot of IPs in between, but I hope you're getting the pattern. Okay, 00 to 0255, 10 to 1255, 20 to 2255, 30 to 3255, 40 to 4255. Like that, down the line, you would have 2550 to 255255. Okay. Now, once both these octets are filled, then what happens? The 0 changes to 1. Okay. And then you have 00 again. Okay. So wherever there's 255, they cycle back to zeros again. Okay. So same logic again. So whatever repeated here from 000 to 0255255, same thing repeats again from 100 to 1255255. Okay, so you have 00 again, 01, 02, 03, goes up to 0255, 10 to 1255, 20 to 2255. Like that, it goes again from 2550 to 255255. Then this 1 changes to 2. Okay, and the 255 cycle back to zeros. So you have 200 to 2255255. Again, I skipped some IPs there. 300 to 3255255, 400 to 4255255, 500 to 5255255, 600 to 6255255. Like that, the cycle keeps on repeating. And somewhere down the line, you would have 25500, 255, 255, 255. Okay. So now, once all these three octets are filled, then this last 0 changes to 1. Okay. And the 255s come back to zeros again. Okay. So whatever cycle repeated from 0000 to 0255, 255, 255 up to here. Same cycle repeats from 1000 to 1255, 255, 255. 2000 to 2255, 255, 255. 3000 to 3255, 255, 255. And similarly, lastly, 255000 to 255, 255, 255, 255. Here's the first IP, and here's the last IP. Again, I definitely skipped a lot of IPs in between, guys. But if you count each and every single IP, then you would get a total of 4.3 billion IP addresses in total, from the first one till the last one. Okay, so yeah, that's a brief intro on what IP addresses are and what are the ranges of IP addresses. What's the first IP? What's the last IP? And what is the sequence of IPs? Now, there's categories of IPs as well, guys, like public IPs, private IPs, classes again. Okay, we'll talk about all that in the next session. What are public IPs? What are private IPs? Where each of this is used? What are classes? What's the range of each class of IP? We'll talk about all this in the upcoming sessions, guys. Okay. But for now, this is about a brief intro on what IP addresses are. And again, how do you classify them? How do you release them from the first one till the last one? And how many IPs do we have in total? So any questions up to this point, Mahinder, Surya? Again, taking a slightly shorter session today, guys. Have a bit of a sore throat. So again, a simpler session. Tomorrow we'll take a much longer one where we we'll talk about the categories of IPs and the ranges of IP addresses in each class. So yeah, that's it. Any questions or doubts up to this point? Okay, guys. So yeah, let's connect back tomorrow at the same time, guys, and we'll talk about a lot more in detail on IP addresses and their classes and their categories. Okay, so that's much more important, much more again interesting as well. Okay, so we'll talk about that tomorrow. Okay, have a good day. Thanks for joining the session. Let's connect back tomorrow at the same time. Bye bye.
Yeah, bye-bye.